Okay, welcome back. This is Mr. Hassan's Maths channel, and here we have question number 11 from the May-June 2013 IGCSE Cambridge Paper 4 Variant 2. This is from the 0580 syllabus. This is a question which is like the last question on a paper 4, one of those questions which requires a bit of thinking outside of the box. They sometimes give these questions as a last question on a paper 4 to give you a bit of a challenge, and it's the last question, so you don't get bogged down with it and lose time from your other questions and get worried about missing the other questions. Normally at the end of the paper, and those students who have finished a little bit early, they have a bit of time to think about some of these questions in a more relaxed manner. All right, so this is one of those type of questions. It kind of builds up and asks you to think a little bit. So it says Sydney draws the triangle OP1P2. OP1P2. OP1, the length is 3 centimeters, and P1P2, the length is 1 centimeter, and the angle OP1P2 is a right angle 90 degrees. Part A says show that OP2 is equal to square root of 10. Now that's pretty straightforward, but you have to show your steps very clearly because they've already given you the value. So of course it's a right angle triangle, so we can use Pythagoras Theorem. So OP2 would be the square root of, now we're finding the hypotenuse, so it's a sum of the squares of the two shorter sides. So it would be the square root of 3 squared plus 1 squared, which is the square root of 9 plus 1, which is the square root of 10. Okay, so it's very important for you to show your steps clearly when they've already given you the answer. So OP is equal to root 10 centimeters. That's part A. Now for part B, it says Sydney now draws the lines P2, P3. Okay, so he's drawn this line P2, P3 and OP3. And these two triangles are mathematically similar. OP2, P3 is mathematically similar to OP1, P2. So they're similar triangles, which means that these angles are both the same, and these angles are both the same, and the ratio of the lengths of these sides are the same. So the hypotenuse of this triangle divided by the hypotenuse of that triangle, okay, sorry, the ratio of the lengths is the same. So yeah, so basically if I divide the hypotenuse of this by the hypotenuse of that, I'll get the same ratio as a shorter side of this with the shorter side of that. Okay, so the ratios of the lengths are the same. So we have to, it says write down the length of P2, P3 in the form root A over B. Now we know this is root 10. We just calculated that this is the square root of 10 in the third form. Okay, so we have to, it says write down, means not much calculation involved, the value of P2, P3. Now I know the ratio of the lengths of the sides is the same. So this length divided by that length will give me the same as this length divided by that length. Those are corresponding sides in these two similar triangles. This is the shortest side divided by the shortest side is equal to the other shorter side divided by the other shorter side. Right? So these are in the same relative position. So I know that P2, P3 divided by 1 is going to be the same as root 10 over 3. So we can say the answer is root 10 over 3. That's using similarity. So this is root 10 divided by 3. Okay, and then it says calculate the length of OP3, giving you answer in the form C over D, where C and D are integers. So I could use Pythagoras to do this because I have the two shorter sides, but I'm going to use similarity because it's going to help us to develop patterns, and we can see that we're going to have to develop some patterns, and I think it will be easier for us to think about this in terms of a pattern here. So I know that the hypotenuse of this triangle divided by the hypotenuse of that triangle will give me the same ratio as the shorter side of this triangle divided by the shorter side of this triangle. Now, how does that work? Let me just draw them like next to each other. Okay, so I'll draw a triangle. Let me make it a bit thinner, just to illustrate what how I'm thinking. I'm going to draw a triangle. Okay, and it's a right angle triangle. So here we have O, P1 and P2. It's a right angle. Now I know that this length in this other triangle is the same as that length here. So I can just take that length. I can copy and paste it. Okay, so this is, try and keep it the same length. This is OP2. Okay, this is now OP2. This is that. I'm just drawing it like standing up on its side. This is OP2. And then I've got similar triangle to that one. And this is now P3. So right angle. Now this length is the same as that length. So we know OP1 is 3 and P1, P2 is 1. We know that this length is root 10 and this length is root 10 over 3. So I want to find what OP3 is. Think about similarity. Now this length here is also root 10, of course. This is root 10, this is root 10. They're the same length, right? So I know that OP3 divided by root 10 is the same ratio as root 10 divided by 3. Root 10 divided by 3. Okay, it's the same ratio as that. So therefore I can say OP3 is equal to root 10 times root 10 over 3, which is 10 over 3. That's the length of OP3. I could have also found it, as I said, using Pythagoras. Okay, using Pythagoras Theorem. Okay, however, I'm trying to develop pattern here for the rest of the question. If I use Pythagoras Theorem, you'll see we get the same answer, and just you can do it as a check. This is going to be this root 10 squared plus root 10 over 3 all squared. So that's going to give me 10 plus 10 over 9, which is, that's going to be, if I make that over 9, that will be 90 over 9 plus 10 over 9, which is 100 over 9. Okay, and all of that has to be square rooted, which is going to give me 10 over 3. Exactly the same answer. So that's just a check to make sure that we were correct in our method here. So we use similarity to find what this length was. This divided by the hypotenuse of this triangle divided by the hypotenuse of its similar triangle is equal to this side divided by that side. Okay, we could have even said this divided by this is equal to the same as that divided by that, same ratio. Okay, so now, so part C says Sydney continues to add mathematically similar triangles to his drawing. Find the length of OP5. So we've worked out that this is root 10 and this is root 10 over 3, and we worked out that this is 10 over 3. Now we worked out that basically in these two triangles, this and this are related to each other, and this are related to each other. Okay, so that's how we worked out the length of this. So in these two triangles, this corresponds to that side, so OP4 corresponds to OP3. The hypotenuse of this divided by the hypotenuse of that divided by 10 over 3 gives me the same ratio as OP3 divided by OP2. This is like the side that corresponds to that side in these two triangles. So this side from that triangle corresponds to this side from this triangle. So this side, okay, from this triangle here, let's call this triangle 1, 2, and 3. So this side from triangle 3 corresponds to this side from triangle 2, and this side from triangle 3 corresponds to this side in triangle 2. So this is equal to 10 over 3 divided by root 10. So we can say OP4 is going to be equal to 10 over 3 times 10 over 3 divided by root 10. So I can just put that in my calculator. I can say 10 over 3 times 10 over 3, which we know is 100 over 9. Okay, and let's put equals and divide by root 10. That gives me 10 root 10 over 9. This gives me 10 times root 10 over 9. So this is 10 times root 10 over 9. So we can continue the same pattern. Okay, I can continue the same pattern and work out what OP5 is, because this is triangle 4, let's say. So the hypotenuse of triangle 4 divided by the hypotenuse of triangle 3. So we can say, I'll just make some space here, OP5 divided by this, which is 10 root 10 over 9, gives me the same ratio as this shorter side of triangle 4 divided by this shorter side of triangle 3. That's going to give me 10 root 10 over 9. Okay, 10 root 10 over 9 divided by 10 over 3. Give that divided by that. So we can say OP5 is going to be 10 root 10 over 9 multiplied by itself, so it's going to be squared, over 10 over 3. Okay, so let's see what that gives us. Yeah. So we can have this, the answer squared, okay, divided by 10 over 3, which gives us 100 over 27. So OP5 is 100 over 27. Okay, so we're using similarity to continue the lengths. So we worked out a pattern that this side is similar to that side, that divided by that gives the same answer as this side over that side. Okay, so you got to think about which triangle you're on. So they're all similar triangles. Okay, so that's the answer to part C. Now we're going to move on to part D. It says show that angle P1 OP2 is equal to 18.4. Now I brought this diagram over from the other page because of course it's better for us to see the diagram. So basically they're telling us to show that this angle P1 OP2, this angle here, let me call it theta, is equal to 18.4. So we can use, of course, here that's the opposite, that's adjacent, it's a right angle triangle. So we can say the tangent of theta is equal to 1 over 3. So theta is equal to inverse tan of 1 over 3. Okay, so theta is equal to, make sure we're in degree mode, yes we are. So we're going to have inverse tan of 1 over 3. Oops. Bracket. That gives us 18.4349. 18.4349. Now when they say show and they give you the answer, it's always good for you to show how it rounds. So write it to a high degree of accuracy. So you have 18.4 degrees. So you must show these steps here because they already gave you the answer, so you should know how to deal with that. Okay, so that's not the answer there. Well, that is the answer there, but that's this is the space where you show the answer. Theta equals 18.4 degrees. It's saying show that, so the whole thing is the answer space. Then it says write down the angle, the size of the angle P2 OP3, which is this angle here. Now, as we mentioned before, these two are similar triangles, and these angles are in the same relative position. So if this is theta, this is also theta. They're both the same. So when it says write down, you just write down the same answer because the two angles are the same. Okay, because of their similar triangles. Then it says the last triangle Sydney can draw without covering his first triangle is the triangle OPN-1 PN. Okay, so like this is the first triangle, the second triangle, the third triangle, the fourth triangle. So this is going to be the n-1th triangle. Okay, because n is that number there. Okay, so P1 is the first triangle, P2 is the second triangle, P3 is the third triangle for P4. So this will be the n-1th triangle. Okay, so we're going to work out first how many triangles can he fit into this without covering the first triangle. So obviously it's to do with the fact that these angles will have to all add up to 360 degrees. So we have theta is equal to inverse tan of 1/3. That's a more exact form of it. And we can say that n-1 is going to be the number of triangles, the number of these angles that will fit, because that's going to be the number of angles, n-1, is going to be 360 divided by inverse tan of 1/3. Okay, so that is the answer. That is what we got there. 360 divided by our last answer gives us 19.52. Okay, so that's going to be n minus 1 equals 19.52. Now, you can't have 0.52 of a triangle. If you make it the 20th, if you make this 20, all right, then n minus, we won't be able to fit. So you can say, let's just work what n is first. N is going to be 20.52. Okay, 20.52. Now, you can't leave n as 20.52. What it's saying is you can have 20 triangles, okay, and 0.52 of a triangle to fit in here. Okay, you want to see how many complete triangles he has to draw that will fit. So obviously that's going to be 20. So n is going to be 20, okay, because it has to be an integer, because a whole number of triangles. Okay, that's why there's that space here. So that's like the extra part. Okay, so n equals 20. You can draw 20 triangles in this, like in the same way, going round, okay, such that he won't overlap. That's the maximum number of triangles you can draw without covering the first triangle that he drew. Okay, so that's the answer to that question. So n equals 20. And there we have it. Right, that's like a bit of a thinking question, especially the previous part. This one is not so bad. The previous part of it is a bit more involved. But yeah, sometimes you do get questions like this, and sometimes you have to think a little bit outside the box and come up with the answer. Sometimes you get it, sometimes you don't. Hopefully you'll get it in the exam if you get a question like this. Just have to think clearly and don't panic. Okay, so this question is part of this paper. If I get to answer any other questions from this paper, I will include them in the playlist that would appear in this area here. And this question, what is it? What topic is it? I guess it's got something to do with trigonometry. So I'll put a playlist here for trigonometry, and also to do with number patterns. I guess it's something to do with patterns, so I'll put it under the number patterns and sequences playlist as well. And you can subscribe to my channel by clicking on this link. Thank you for watching, and I hope to see you soon.